So I want to mention that you can also extend the chain rule for two independent variables to any number of variables. So let's look at an example. Let's look at the following. Find the partial derivative of w with respect to s and the partial derivative of w with respect to t when s equals 1 and t is going to be 2 pi for the following function. For w equals xy plus yz plus xz, where x is going to be s cosine t, y is going to be s sine of t, and z is just going to be t. So let's set up our formula for this first one, for the partial derivative of w with respect to s. W has three variables, x, y, and z, so you're going to have three terms. You're going to take the partial derivative of w with respect to x and multiply by the partial derivative of x with respect to s, the partial derivative of w with respect to y, times the partial derivative of y with respect to s, and then finally the partial derivative of w with respect to z, partial derivative of z with respect to s. So we need to compute these partial derivatives here. So the derivative of w with respect to x would be y plus z. Let's go ahead and just compute these partial derivatives now. The partial derivative of w with respect to y would be x plus z, and the partial derivative of w with respect to z would be y plus x. So I found this term, and this term. So now we need to find these other ones. The partial derivative of x with respect to s, so that would just be cosine t. The partial derivative of y with respect to s, that'll be sine t. And the partial derivative of z with respect to s, there's no s's there, so the derivative would be 0. So then I'm going to plug in my formula for y, z, x, and z there. I don't have to worry about this second term because it's all 0. So my partial derivative of w with respect to s would be, it'll be s sine t plus t cosine t, and then x, which is s cosine t plus t sine t. And now I just need to plug in my values, and I'm told in my problem that s is 1 and t is 2 pi. So we're going to plug those in. So the partial derivative of w with respect to s would be sine of 2 pi plus 2 pi cosine of 2 pi plus cosine of 2 pi plus 2 pi sine of 2 pi. Well, sine of 2 pi is 0, so that whole second term is 0. Cosine of 2 pi is 1. So this is going to become 2 pi. That's the partial derivative of w with respect to s, will be 2 pi. So we've done half the problem. I know it's a little long, but now we need to repeat what we just did, but instead of taking our partial derivatives with respect to s, now we're going to take them with respect to t. So the formula we use, partial derivative of w with respect to t, you still are going to have 3 terms, 1, 2, 3, and then you'll have the partial derivative of x with respect to t, the partial derivative of y with respect to t, and the partial derivative of z with respect to t. So we found some of this stuff in our last problem. These 3 partial derivatives we've already calculated. Y plus z was the first one. X plus z was the second one. And y plus x was the next one. So these 3 I copied down from the last part. And now you're going to have to go back to your x, y, and z equations, which are, again, right here, and take the derivative with respect to t now. So it'll be here, you should be getting minus s sine t. You'll get s cosine t. And here the derivative of t is just 1. So again, you're going to plug in. For y, it was s sine t. Z was t. X was s cosine t plus t, s cosine t, and then plus y plus x, y sine t, or sorry, s, this will be s sine t plus s cosine t, and then plug in. You're going to plug in again. S is 1, t is 2 pi into this up here. So you'll get the partial derivative of w with respect to t would be sine of 2 pi plus 2 pi minus sine of 2 pi plus cosine of 2 pi plus 2 pi times cosine of 2 pi plus, and then finally that last term, sine of 2 pi plus cosine of 2 pi. Well, sine of 2 pi is 0, so this term is 0, which means that whole first term is 0. So the partial derivative of w with respect to t would be cosine of 2 pi is 1 times 1. Sine is 0 plus 1. So you're going to get 2 plus 2 pi. And that's going to be equal to the partial derivative of w with respect to t.